Good morning all. So yes, indeed, I would like to switch gears a bit, and although it's very cool to use x86 or any virtualization to prevent you from buying expensive vendor chassis and hardware, I want to switch gears and say let's look at x86 and virtualization to actually simulate labs, build labs, do your validation and testing, because, well, certainly where I work, they don't buy us real routers and give us real routers to test on, except when you actually do some data plane testing. But for the majority of stuff, control plane testing and limited data throughput is actually more than sufficient. So with that then, I think let's move forward, and this is going to be fairly awkward without a clicker, but can we move? Okay, so can we move forward, please? And another one. Another one, please. Thank you. So, labs are actually not a privilege anymore. It's actually a right. So if you are actually trying to do any sort of network setup and configuration, that's actually needed. So yes, it's there for education and learning, but it's also there for validation and continuous development and integration. So pretty much what we do on a daily basis is actually using labs. So if we move forward, typically how labs were run. Can we move forward, please? Yeah. Was something like this. And although it was cool 10 years ago, it gets very old if you have to point and click to build up a large, elaborate lab. So if we move forward, if you look at the IT guys and if you talk to IT guys, they typically accuse the networking people of being slow. So they could spin up applications and application stacks, and they would always complain about how the networking people are slow. If we look at how they actually do this, they actually take some declarative ways, so feeding typically YAML files, and those files would actually declare what that application stack should look like. And they would run it through a infrastructure as code engine, and there's numbers of those, whether it's Pulumi, whether it's Ansible, whether it's Terraform, doesn't really matter. And that would actually take the declarative input and actually build up the application stack. So this is cool because every single time that you run it, you get exactly the same result. Now, if we move forward to the next slide, what if we bring that declarativeness to network labs? Isn't that awesome? So what we can actually do is we can define a topology lab, so declare that this is the way my lab should be. I would declare that I would like different nodes. I would declare that I want different links and endpoints, and we run it through Containerlab, which is a piece of software, open source, freely available, and that would actually build up our network infrastructure, our simulated lab. And every single time that would be exactly the same because it's 100% declarative. So if we move to the next slide, then you would say, well, this is cool, but why as code? Well, first of all, it's Git friendly, so that means that it's open for collaboration. So it's very easy to share labs, and if you work in a larger organization or you want to share labs or try to troubleshoot issues in your network, and you've spent half a day to build up a lab to reproduce that problem, you want to share that very easily with someone. And it also supports versioning out of the box. So a very cool way and a very lightweight way to actually share labs and exotic lab topologies. If we move to the next one, please. Containerlab actually supports a range of different node types. So yes, by nature and natively, it supports containers. So all the network OSs typically these days are moving from virtual machine-based network operating systems to container-based systems. Where do you get those? You get them by your favorite network vendor. They're fast to spin up, they're lightweight, doesn't take a lot of resources, and from a shareability perspective, it's fairly easy. There's obviously a number of different containerized network operating systems already available from all the usual suspects. And if we move to the next slide, we also support within Containerlab all the Linux containers. So that allows you to actually build up a lab that not only has network operating systems or routers, but also your whole telemetry stack. So for any of the modern network management systems, where you have flow collectors, telemetry collectors, Prometheus, Grafana, all of those things can actually be containerized, which means that you can actually build up a lab, simulate that lab, spin it up in a matter of seconds, and you can actually be up and running. If you move to the next slide, how does it actually work then? So it's very simple. If we move on, you can move on another one. We actually start by installing Docker and Containerlab itself. Containerlab is a single binary. It's written in Go, so no issues there. And then you actually get a topology file. And the topology file you can build up from scratch for yourself, or we actually provide a number of different topology files on GitHub itself, or you can actually get them from anywhere else. Once you've got that, you actually deploy that with Containerlab, and then you start to interact with your lab. So Containerlab will actually spin up all the containers, create all the plumbing for you, all the network connections. And once you've done with interacting with your lab and done your testing, you can actually destroy that, save it first, maybe from a versioning perspective, and then destroy your lab. If we go to the next slide, can we move to the next slide? Thank you. So getting it installed is fairly easy. We have convenience installer scripts for Linux, for WSL, as well as for Mac OS. And that would actually install Docker for you, as well as Containerlab, if it's not there already. And that's what you need to do. If we move on to the next slide, then from a topology file perspective, it is actually very simple. We actually give the lab a name, and then we actually start to define our nodes. So there are different kinds within Containerlab, and that would actually just define what you are trying to simulate. Is this a Nokia SRL? Is it a Nokia SROS? Is it a Linux device? Is it a Juniper? Is it a Cisco? Is it a whatever it is you're trying to simulate? The device name itself, and the image it's running. And you can actually have startup config as well, which means that you can actually build up a lab already running. You don't need to build it up from scratch itself. If we move on to the next slide, to build up topology is fairly simple as well. So you would define your nodes, and then you would have a link section where you actually just define that you want a connection from node 1 to node 2, and you specify the Ethernet interfaces used for that. And that would actually give you a logical view on the right-hand side. If we move to the next slide, then once you've deployed that, once you've defined your topology file, you would deploy that. So do a Containerlab deploy with your topology file, and once it's done, it would actually give you this nice output that says, okay, I've started up these nodes. Containerlab will also add host names in your etc host file so that you can define or interact your devices by host name itself. It would give you the container ID if you want to do logging, the image is running, the status, and the IP addresses that you can connect to it. How do you interact or get to your router then? Just do an SSH to the name, or if it's a Linux container, probably a Docker exec IT container name itself. If we move on to the next slide, Containerlab also then allows us, can we move to the next slide? Thank you. Containerlab allows us to do lab-wide actions. which is save. So you can actually just do Containerlab save. Guys, can we move to the next slide? Thank you. Do a network-wide save, so Containerlab would know what are the save commands because we know what are the kinds that we are supported. So a save for a Nokia SR Linux would look different from a Cisco, from a Juniper, from a, whatever you're trying to run. And the next question you probably want to know is, next slide is, how do we actually get the images? Where do we get them? Well, like any of the other lab software, speak to your favorite vendor representative. If it is SR Linux, so containerized SR Linux from Nokia for the data center portfolio, we don't want your email address, we don't want you to register, you can just do a Docker pull straight from the internet, no licenses, super easy. Any of you guys can actually try it out today even. If it's from any of the other vendors, speak to your vendor representative. If it is VM-based images, we need to run that through a tool called VRNet Lab. And VRNet Lab would actually, you would feed it the QCOW image or the OVA image. VRNet would repackage that as a Docker container, and we can actually deploy that with Containerlab itself. So this is cool because all of a sudden it allows us to actually run VM-based and container-based network operating systems in a single lab platform. Awesome. If we move to the next slide, then you can actually deploy these labs, once you're ready, and by a straight Git push, you can actually upload that to your favorite Git environment, and that's ready to be shared to any of your colleagues, friends, or acquaintances, and that they can just do a Git pull and deploy that lab. In a larger environment, of course, you can leverage registry, so a centralized registry where you actually store all these images, so you can actually just do a pull from your private registry itself. So very easy to actually share labs then within a larger environment. If we move to the next slide, you would say, well, this seems like a lot of effort to create lab or topology files. We actually do publish a lot of topology files already, and Containerlab allows you to even deploy with a remote URL. So it would actually download the topology file for you. So you can actually just do a Containerlab deploy with the Git URL for you, and it would do that by itself. If we move to the next slide, this is an example, and again, you can move forward. This is a complete data center interconnect lab that we've published. It's like two data centers that we simulate with some leaves and spines clients, data center gateways, a WAN component, MPLS component to connect this, and then a sort of a mirror image on the far end data center slide. So that's how you do it. Very easy to deploy this. If we move to the next slide, another one you can go. It's actually as simple as, and I don't think the video is showing, so apologies for that, but it's actually just a Containerlab deploy and your topology file, and it would actually build up, deploy all the containers, create all the network links and the connections, load up the startup config, and you are ready within seconds to start to interact with that lab. If you move forward then, again, how you interact with it is, once the output that is there, you can move forward once more, and once you're ready, and well, if we had a clicker, this would have worked, but and a lot cooler. But you can then interact with your lab itself. So some of the new things. So for the people that have actually used Containerlab, just out of interest, show of hands, has anyone actually used Containerlab or is using Containerlab? Yay! Awesome. Well done, guys. So for the guys that actually use that, that's quite cool. It's sort of revolutionized my life. There are some new stuff, maybe stuff that you are aware of already. One of those are EdgeShark integrations. So Siemens has actually created a very nice piece of software called EdgeShark, and they actually create a UI that shows or visualizes all the containers that you run with the connectivity. So it looks at all the bridges and the network connectivity itself, and allows you to do some packet captures as well. So what we've done is we've integrated EdgeShark into Containerlab itself, and that allows us then to do some packet captures remotely as well, which is quite cool. And that just gives you an easy way to do some packet captures on your lab, because as network engineers, we all know that if there's no PCAP, it didn't happen. Okay. Next slide then. One of the other things that we do as well is we say, well, this is awesome, but you still need a VM to run this topology file. And although Containerlab makes it very easy to deploy this lab, you still need a VM. Well, not anymore. If you have an account on GitHub, they actually give you some credits to run some workloads every month. It's not a lot, but it certainly can get you there. And Containerlab actually supports running in what they call code spaces. So code spaces is a GitHub feature where you can actually run your infrastructure or some workloads. And you can actually run that then for free without having your own VM even. So yes, of course, this works better with containerized workloads because they are lighter in footprint, but just bear in mind that, it's not unlimited processing that they give you, but there's quite a bit that you can actually do in a month's time. Word of warning or a tip maybe, once you're done, please shut down your lab, otherwise you will just keep on consuming those credits, and before you know it, it's all gone. If we move to the next slide then, another new enhancement is we actually introduced a VS Code plugin. So for the guys that actually do use VS Code, it's a simple plugin. You would get it from the marketplace just like any other extension within VS Code itself. And what this allows us to do then is it would discover all your Containerlab topology files running on your server, and again, it's either local on your machine or to a remote hypervisor or Docker host. But that would then give you a visualized way of all the labs. You can then interact with those labs, so you can deploy those labs, you can destroy those labs, you can inspect those labs. Quite cool. And you can also edit your Containerlab topology files from there. Not only that, you can then also interact with your lab, so you can actually click on your lab devices themselves and SSH to them. They also display all the interfaces, the app status, and you can also do a packet capture from there. So there's a packet capture icon, and we also support adding link impairments to any of the interfaces. So you can add some delay, some jitter, packet loss. All of those things can be done leveraging Containerlab itself. There's some YouTube video links for this one and the previous one as well that you can go check out to actually see all the details for the VS Code plugin, for EdgeShark, and so that you can actually get the gist of it. If we move on to the next slide then, I think wrapping up, we believe that Containerlab is way bigger than Nokia, and this is our way to contribute and give back to the community and say, this is an awesome tool, please use it, it makes everyone's lives easier. It's declarative, so we use Git, of course, which makes it super shareable. It's container-based first, but we can also, as you've seen, run VM-based network operating systems. It's lightweight and it's open, and for our open source initiative, we actually have more than 100 contributors already, which is quite impressive if you think about it. We have a ton of downloads already, Last time I checked, there was more than 280,000 downloads of Containerlab, so very popular. We keep on getting very good feedback from the industry. I just saw earlier in the week, one of the guys published all of the CCIE prep labs and exams using Containerlab. So the guy gets it. That's why Containerlab was made, to actually share labs with configurations in an easily, shareable manner. We have, in the meantime, support for more than 30 network operating systems. So go check out containerlab.dev for whether your favorite NOS is supported there. And in 2024, we actually published more than 100 labs on GitHub, which you can just download. So there's examples of all the configs and the topology files itself, which you can download and deploy and use for your networking needs. If we move to the next slide, these are all people that actually use Containerlab. The list is not exhaustive. There's obviously more, but these are guys that openly say Containerlab is cool, and we use that. If we move on to the next slide, here are just some example labs that's available. If we look on the left-hand side, this is a very good example, the SR Linux telemetry lab. So it's a data center topology. What's cool about that is you can deploy it, of course, whether you don't need a license or anything. You just do a Docker pull and a deploy. But it also includes a modern telemetry and management stack for it. So using GNMIC as a GNMI collector, use Prometheus and Grafana for visualization of that, and there's some logging stacks as well, so quite cool. If you're more into the WAN side, there's some segment routing labs, and probably for this audience, there's also a peering lab that one of my colleagues have written, where they actually peer with a Nokia SROS router with FRR, and there's some OpenBGP and Bird software. So if you want to practice your peering expertise, you can actually just download the lab and do that. If we move to the next slide, how do you actually get in touch? Head on over to containerlab.dev. Very well documented piece of software. Everything that's needed is there. If you don't succeed, which is sort of hard to believe, but we actually have a Discord server as well, so where you can find some support. So you can ask on the Discord server for some support. It's not just manned by Nokia people. Actually, it's a community effort, and we've got a lot of good feedback as well, where people are saying, well, this is so much quicker to get some access and support than raising GitHub issues. So quite a cool initiative. Lastly, if you look at GitHub, all the topology files and labs are actually published there, but they're also documented on containerlab.dev. So lastly, hit me up while we're drinking coffee for some Containerlab stickers to show the love for Containerlab. Pimp out your laptop. Tell me how you plan to use Containerlab if you're not using it already. And if you use it,